The waiting times for 16 patients at dental surgery are recorded for a particular week on the following 7-week plots. Is that the correct question? There's no numbers to put in for week 2, is there? Further down, right, fair enough. Okay. What is the mode of the data? 12. How many 12s are there? 3 12s. How many people are there? 16 people. Out of 16 people, who's in the middle, Ben? 4.5. Sam? Huh? It's 4.5. 16 divided by 2 is 8 and 9th. So who's 8 and 9th? I don't think you did. Oh, well, it's 24 and 25. Does that make sense? They're number 8 and number 9 on the list. So what's the average of 24 plus 25 divided by 2? 24.5. Right, find the mean. Lads, whatever you type into your calculator, please put here. Because you don't want to be, anything you type into the calculator should go onto your page, if you can. So here is the calculation of the mean. That's it, what's it, 30, 31, 32, 34, plus 34, plus 44, divided by, add them all up and divide it by 16. And what do we get? Anybody get this? 22.6. Plus 7. 22.7? Okay. Now, lads, I'm just going to quickly show you the marking scheme. So we'll just we'll address next page. Does it give me new numbers? So it gives me these new numbers to write into the original stem and leaf plot. Okay, can anybody call out what I have in the first one? Yeah, next one. Yeah, those two. Yeah. Next one. 2, 5, 5, 6, 7, 8, 8. Yeah. Next one. 3, 7, 8, 9. 3, 7, 8, 9. Yeah. 2. Yeah. 0. Now, the one thing I'm noticing is if we compare these, 5 patients were in the 30s last time, and there's only 1 patient this time. Would you agree with that? Or would you agree that 6 patients had over 30, but now only 2 patients were waiting over 30? So do you think that they've increased their productivity? Do you think they're better in the second week? Would that make sense? They seem to be a bit better in the second week, don't they? Now, what calculations did they ask you to do on that? All right, done that. That's done. Is that anything out there, see? And for some reason, I don't have it. Oh, that's it. Whoa, they sort of backed out with that. If I was designing a test and if somebody else was designing a test, what we would have asked you was, which status do you think the dental surgery became a better business in week 2? What would your answer be? Yes. More than likely yes, because of most of the times being under 30 minutes now. Would you agree with that? More times under 30 minutes. You calculate the mean of both sets, wouldn't you? And you go, the mean of week 1 is maybe larger than the mean of week 2, and that means that people on average are waiting less. Stuff like that. All right. Now let's keep going. 10 points to mark, and we have to do the following. Strong positive correlation. So what do you think? I was going to draw a line, or pretend line, and then what do we just do then? Just go 1, 2, 3, 4, 5, 8, 9. And you know? And then you can just, if you aren't allowed to draw the line, you can just whip that out, can't you? Now, if I look at the marking scheme, wonder did they draw a line? The marking scheme didn't draw a line. But I don't think you'd lose marks for putting the line in, if I'm being honest. It doesn't say anything about losing marks with the line or not. So there's no way of marking it, basically. Okay. It just says correct entries If you have 10 correct entries, you're good to go. Or something like that. All right, let's keep going. What about a strong negative? What do we do there? Yeah, and just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Strong negative. Cool with that? Now, next one. No correlation. No correlation is essentially a box. So what do I do with the box? Spread out evenly. 1, 2, 3, 4, 5, 6, 8. And you agree there's no way you can put your line anywhere, isn't it? You can put your line this way, you can put your line this way. You don't know where to put the line, do you? So that means there's no correlation. Alright, awesome. That was easy money. Now, next one. This next one. We all happy with this? Alright. This is the third one of these we did now, isn't it? So we're well and truly practiced on this. Did I skip something? Am I okay? Alright, what's the margin of error? 1 over square root of 1,000, which is 0.0.
362, which is 3.2.
I'm confused.
It's 0.
Yeah, but just give it to me in decimals first. So what's 1 decimal?
0.039.
Yeah, so there we go. Multiply that by 100 and you get, yeah. Couldn't understand there, it's just on a different level. Now, what do we get next, lads? 95% confidence interval. How do we do that? We know it's 54% for the no complaint, do we? Yeah, add and take away 3.2. So it's 54 take away 3.2 and 54 add 3.2. So what's our margin of error then? I'm getting 50.8% less than P less than 57.2%. Now, just your percentage. So, does it have to do a hypothesis test?
No.
It doesn't. Alright, just while I'm here, I'm going to make it a hypothesis test up. Alright? So, I'm going to make up a part 3 right now. I want you guys to do part 3 for me, okay? Kenny newspaper. Right. Kenny newspaper claims that what? What? Kenny newspaper claims that 53% of, be quiet please, 50% of the population supports the no campaign. Okay, what I want you guys to do is create a hypothesis test to test this out. Alright, I'll just go. Does everybody know what a hypothesis test is? H0 is the number of people who support the no campaign is 53%, and H1 would be the percentage of people who support the no campaign is not 53%. Does that make sense? Okay, so write that down. So H0 is percentage of people who support I wonder why I'm doing this. Now is 53%. Now you can be really lazy. The H1 is usually an absolute rip-off of the H1 is usually an absolute rip-off of the H0, except you change one word. So H1, and what's the only thing I need to change? It's not 53%. Now, unlike the previous two questions we did in this, can we reject H0? And if so, why not?
Yes.
I don't think we can reject it. Reason being, is 53% within this confidence interval. The confidence interval says the answer is somewhere between 50.8 and 57.2. Is 53 in that region?
Yeah.
Because it's in that region, we accept H0. It's possible that it is 53%. If it was outside the region, you'd reject it, wouldn't you? So 53% is inside 95% confidence interval. And then you just say accept H0. Right. All right, lads, which one is it? Heights. Numerical, continuous, because heights is measured. You're never exactly 180 centimeters, are you?
No.
No. All right, make sure you take these down there, Moda. All right. Now, a sample of 1,000 students was made up of 500 boys and 500 girls. The data from 500 girls was used to create the information shown on this table. Use the information table to estimate the mean height of the girls using mid-interval values. No bother. All right, what's the middle of the interval, lads? Middle of the interval, guys? 147.5, 152.5, 157.5. Just keep nodding on 5, is it? Yeah. Next one. 67.5. Next one. Yeah. And the last one. Oh, sorry, second last one. Now, what I'm interested in here, guys, is I'm going to check the marking scheme. Once again, I'm going to check, do you need to show any workings? Or is there anything that you could show that get you a lot of marks for not much effort, okay? So we'll go to the marking scheme one more time. We'll work our way down. And what we'll see is, oh, it actually doesn't have it here. You can see that the workings aren't that, what's that word? Not that detailed. So I think you'd get away with it. So here's what I want you to do. You put all that into the calculator. So does everybody remember you put your frequency on? Does everybody know how to do this? What you get as your mean? Has anybody got it done?
Wait, that's what I get.
Yeah. Oh, it's 100 ants? Yeah, I think that makes sense. Any decimals, Peter? Why don't we all try in the calculator now, just to make sure we can do it. For those of you that are doing this, you go to mode, statistics, one variable. You need your frequency on. If your frequency is not on, you go to shift, setup, you go to stats, and you put your frequency table on. Then we go back to mode, statistics, one variable. Have you got your frequency on your calculator? Yeah. So I'll just do 147.5, 152.5, 157.5, 162.5. I'm just currently counting up in fives, so I don't have to look up too much. Then I have to go 172.5 and 177.5. So 177 the last one. So there is a lot of work in this. And then I have to go up here and enter in how many times each one happens. First one's 15. Wait a minute. 15, 48, 80, 112, 125, 81, 29, 10. All right. A really quick way of checking your answers is you go to options and you click data. Oh, wait. You go options and you go down, I press down for variable. Okay. If I press N, how many numbers am I expecting? How many girls did he interview? I thought he interviewed 500. My N value is 500. That means I put more likely put the numbers in correctly. And then you go options for me, variables, and then I'll go for number 1 for the average, and I get 164.43. Anybody else match me on that? Yeah, that's okay. What calculator do you have? So are you not just going to press Shift 1? Alright. What's the largest possible value for the range of heights of the girls in this sample? Largest range possible, lads. What do we think? This girl is going to be as short as possible, which is 145. This guy will be, this girl will be as tall as possible. There's an argument to be made there. Can that girl be 185? She's not allowed to be 185. Why? She'd be ranked from 185 upwards, no? So I'd have two answers here, and I'll explain my two answers. I'd have 185 take away equals 40, but I'd also put in, but 185 would not be in that interval. What does that mean? If she was 185, she wouldn't be classed there. She'd be classed in the next interval up. So I'd say 2 decimal places. To 2 decimal places, I think it's 184.99 take away 145 equals 39.99. If I'm being really to the letter of the law, that's how I do it. It doesn't mean it's right. But that's the median heights. The median height of the girl was 164.5. Explain what this means in the context of the 500 girls. Well, might as well use the marking scheme on this one. Here we go. What this would mean is, if the median is 165, what it would mean is 250 of the girls are 164.5 or taller, and 250 of the girls are 165.5 centimeters tall or shorter. The median cuts it in half, 50% below and 50% above. Does that make sense? It doesn't always cut it in half, but in theory it's meant to cut it roughly in half. Alright? Now, Peter. Now, okay, let's keep going. What's this for? Have we not already done this? Oh, the percentage. So, if you go back to your original table, which is here, and you just divide each of these numbers by, not 500. Yeah. So everybody, you're going to divide this by 500 and then multiply by 100. If you want a really easy way of doing it, just divide it by 5. Each of these numbers divided by 5, and you should be able to get the percentage you're looking for. Is that alright? So let's begin with the first one, Peter. Next one. Next one. Next one. Yeah. 170. Yeah. Yeah. If you add all them up, what you have to get? 100. Okay. Awesome. D. Use the data in table 2 to draw a histogram showing the percentage of girls in each of the height categories. Alright, Peter, will you help me out one more time? What's the first one? 3, yeah. Next one? Is the interval just in 5s, isn't it? So next one's 9.6, you said? Yeah. Sorry. Just messing up my rhythm here. Alright, 9.6 around there, yeah. Next one? 16. Yeah. Okay, 22.4, which is roughly halfway there. Keep going. 25. Yep, not that fast. 16.2 is, yep. Excellent after that. 5.8. 2. Alright. So, boys' heights. We can see that the boys are symmetrically skewed. Would you agree with that? Mostly symmetrical, isn't it? What about the girls? I'd say it's slight positive skew, but not much. Girls is symmetrical with a slight positive skew, where it looks slightly like your right foot, but the boys one is very close to symmetric, or normally distributed. What does it want from me here? Histogram shown the percentage of boys each category is given above. John examines both histograms comments. There are roughly twice as many boys as girls in the 175 to 180 category. Do you support his claim? Alright, let me see. 175 to 180. So, oh dear. 175 to 180, 170, sorry, 175 to 180, sorry, excuse me. 175 to 180 is what's a 2.6? And what is it in the boys? What?
It's like
10 points?
11.
Yeah, it's about 11%. I'd say, no, 11% of the boys, that's, I said the boys are roughly at 11%. So, no, is the answer. Boys are at roughly 11%, while girls are at, was it 2.6%? Which is not a half. Is that okay? Not twice as much. Alright, happy enough with that. Is that it? Oh god. No. Mary examines both histograms and comments. I see that there are more tall girls than tall boys. Does your histogram support her claim?
Yeah.
There's more tall girls than tall boys. Yeah, you could roughly add them, couldn't you? That's 24, that's 16-ish, that's 5. What happens if you add all these numbers together?
41.
Lads, when I add all these together, I roughly get 47.6. I'd say 47.6 people are over 160. While on this one, what do we reckon? Call that 19, call that 17, call this one 11, call this one 9 or 10. What do we get there? 20 plus that? 46. So, here's the issue, and this is a bit of a worded answer. What I can say is, using approximate values, we can see that the amount of girls and boys over 160 is roughly the same. However, there's many more boys at the higher rates. There's many more boys above 75. So I say there's 20% of lads are above 170, while only 7.6% of girls above 170. So I'd say that doesn't support our claim. The really tall people, boys are more dominant. Does that make sense? So you'd have to do some sort of worded answer like that. Okay? I don't agree because I think there's far higher percentage of males in the higher height categories than females. So I'm talking about over 170 centimeters. Boys have a higher percentage. Once again, this is a sample paper, not the real thing. Now, the mean height of the boys in the sample is 166.7, and the standard deviation of their height is 8.9. Assume that the boys are normally distributed. Use the empirical rule to find the interval that contains 95%. Peter, 95%. How many standard deviations is that to the right and to the left? No, 68% is 1 either side. 95% is 2 standard deviations either side. So what do I need to do with 166.7? I need to add it to 2 times 8.9. I also have to take away 2 times 8.9. What you get when you do that? Surely somebody got that right. Remember the bell curve was 68 and 95. So what do you get when you put that in? 148.9. And the other one. 184 oh dear. 184.5. So in between, I can't spell in between anymore. Between 148.9 centimeters to 184.5 centimeters. Okay.